Hello everyone, I'm Jyoti Sharma and I will be the TA for this course, Climate Change Extreme Event. The live session will be from 6 to 8 p.m. and it will be happened every Sunday. Uh, I think from this July to October because we need to cover 12 weeks. And yeah, so let me show you. Okay, so this is just brief introduction of myself that right now I'm a PhD final year student in ISO Bhopal and I did my master's in environment management from Forest Research Institute Dehradun and my BSc from University of Delhi. I already have qualified UGC NET GRF and ICR NET and right now I'm a PMRF research fellow. Till now, I have completed 5 NPTEL courses as a TA, and this is my sixth TA-ship that I'm trying to complete for this course, climate change and extreme events. Okay, so this is how we will proceed. The thing is, because this live session is basically aims to solve the assignment questions that has been given to you. So, yeah, to solve this, so I have a lot of MCQ question that will be similar to your assignment question, and we will try to find out the solution of this MCQ question, but with the discussion, and that's why I encourage you people to please participate. You can also write in the chat box whatever answer you are thinking, right? So, mostly it will be 4 options, and among that 4 options, the one option will be correct, and that you have to tell me. And if you are giving me even the wrong answer, then please don't worry, please participate, because I think that's the way how we will learn together, right? I will try to correct you at some point, you may also try to correct me. So yeah, so interaction and participation is highly valued. And okay, if you have any query before starting, you can just write in the chat box, or otherwise we can proceed. Before that I wanted to ask you about your background. So are you the climate are you studying the climate science, or your background is different, so that I have some idea that how I should proceed from basic level to advanced level. No doubt I will start from basic to advanced, but I should have knowledge that what is the background of my audience. So please, can you write in the chat box quickly about your background? Okay, Shankar, this is basic level. Yes. Dr. Brunda, allopathy, doctor. That's great. Shankar, you are from agriculture. That's nice. Uh, Kailash, MSc Environment Science, perfect. Ashwini Soni, that is climate science. Okay, can I get more answer, or should I go quickly? Okay, one is PhD in geography. So yeah, this climate extreme is really related to the geography also. Water resource engineering, this extreme, we will study about the flood and probability conditioning in the later stage, and that's how this will help water resource engineering part also. BSc mathematics, now MSc in data science. Okay, that's great, because climate science is all about physics, maths, and data science. Because right now, as I told you, I'm a PhD student, and I'm dealing with the data, the climate data, and it's very huge. We have to have the data from climate model, from satellite data sets, and that's how we should have a very nice command on data science. Geography. Okay, so I think I week one was interesting about the climate change. Yeah. So um, we will talk about what do you mean by climate change, exactly what is the definition from the perspective of science, because everyone right now in the lame language is saying, okay, there's the climate change and this and that, but now we will learn exactly what is the climate change, right? Will this session be recorded and available later? Yeah, so recording has been started, and this session will be recorded and will be uploaded on YouTube, and we will share you the Excel sheet in which there will be the link for the recorded session, right? Okay, so what I have learned is that you are fantastic, that you are people from geography, from maths, from data science, from agriculture. And I think the good part is that whatever the field you belong to, the climate change is the pillar that connect to every field. So let's say if it is agriculture, if I tell you about my PhD topic, then one study I did about how forest and crop, and what's the difference, different impact of the climate it will happen if it is a forest and if it is a crop. So yeah, very relevant course I think this is, and we will start from very basic, because this week is basic. We will start with weather and climate, then climate change, climate extreme, and then some summary. Okay, so I think we should start right now. Okay, now I'm starting with the MCQ that are related to the lecture one that has been uploaded by Dr. Somil Savankar sir. This question is very simple, and the question is related to the definition of the weather. So we have two terms, right? Weather and climate, and we want to learn what's the difference between these two terms. Sometimes we people say, okay, the weather is good. Sometimes we are like, the climate is good. But really, what is the difference between these two terms, weather and climate? So my question is, weather refers to the state of atmosphere at, and I have four options: a specific place and time, a global scale for centuries, a region over 30 years, a continent over decades. So, can you write in the chat box whatever answer you are thinking is the right one? Okay. Okay, so I think most of you agree with the option A, that is a specific place and time. And absolutely, you people are right that this is the state of atmosphere. So this is actually temporary state of the atmosphere at a particular place and a particular time. So, for example, right now I'm in Bhopal, and let's say it is raining, right? So this raining event is nothing. This is just a weather. This is not a climate, right? So this is the temporary state of the atmosphere. Another day it can be sunny. So what I can say is the weather is very sunny. Another day it can be like we can face tornado. Not a tornado is not in India. So, for example, we have hailstorm and something like this. So these are the event which are related to the weather, right? So it can happen anytime, and this is just the state of your atmosphere at that particular time and a particular place. So, for example, again I'm giving you the example of Bhopal. Let's say if it is a rainy season here, and somewhere in the south part it may be it may be sunny day. Okay, so the weather is sunny in the south area and the weather is rainy in central part of India. So this is specific to the place and specific to even the time, because after 1 hour there may be there will be no rain, right? So this is how you correctly told me that A is the right answer, that a specific place and time. This is what I got from the Wikipedia, not from Wikipedia, from Google, that weather is the temporary condition of atmosphere at a place and even at a time. So if it is a temporary, then it means we are having the reference of time. And climate is your overall average weather at the place over a period of time. So, for example, in India, or let's say in the central part of India, what we are having is what we learned that over last 30 years, from July to September, there is a rainy season. Okay, it may be that there are some exceptional. Every day it is not raining, but we what we have learned that over 30 years, these are the time, this is the season from July to, let's say, September, there is a rainy season. So the average weather is that this season we are calling as the monsoonal season, right? Or the rainy season. So this is how we are establishing the climate from weather. The average of your weather will be your climate. Okay. And can you tell me the overall climate of India? What kind of climate we have over India? Either it is tropical climate or it is temperate climate. What kind of climate we have over India? Can you write in the chat box? Yes, Sahil told me that is it is tropical. Yeah, I agree. Yeah, and tropical means what? How you are defined that this is a tropical climate that we are experiencing? So, okay, what you can say is, okay, because our region is near to the tropics, or arranging between the tropics, and that's why we are having the tropical months, tropical climate over India. What I will tell you that in the south part we have typical tropical climate. Yeah. So Bhushan told me that tropical climate because near to the equator. Yeah, but if we are going up near to the Himalayan area, or up from the Madhya Pradesh, we are not having typical tropical, right? Tropical means that we have huge temperature every day, and in the evening time there may be a rainy season, as we have in the African part, right? So our south part is basically have very typical tropical climate. But if we are going up, if we are going away from the equator, then we don't have typical. No doubt, India is the part of the tropical climate, but typical, if we are going up, this is not the tropical, because not just sunny days we also have extreme winter also, right? And in the tropical region we don't have much winter season that we experience in the near to the equator. And that's why I told you that overall India is tropical country, but typically to the south it is tropical. But yeah, if we are going up, then it is something mixed, right? Temperate, you can say. Okay, this slide I took from Somin sir's presentation, that weather refers to the state of the atmosphere at a specific place and time, and it includes the variable temperature, humidity, precipitation, wind, and pressure. Uh, you may have heard this terminology. Temperature is like common word. Humidity is again common word. Are you aware of the precipitation? What's the difference between precipitation and rainfall? What's the difference between precipitation and rainfall? In climate science, we most of the time talk about the precipitation. The terminology is precipitation, but not the rainfall. Why? What's the difference between these two terms, precipitation and rainfall? Wind, you are aware, pressure. Okay, I got one response that rainfall is a type of precipitation. Yeah, and someone also told me precipitation can be in any form, rain and snow. And you are absolutely right that snowfall, rainfall, these all are the part of precipitation, right? Either it is in the form of water droplets or in the form of uh, ice or snow, and these all be the part of the precipitation. So precipitation is the big term, and the sub part may be uh, rainfall, snowfall, and so on, right? Okay, the characteristic of weather is that it is short term. Within minute and second, within week, it can change, and it is highly variable. We agree with this. Example are a rainy afternoon or a snowstorm. Okay, this is like we already have discussed. You need to tell me the example of weather: tropical climate, polar climate, a rainy afternoon, arctic amplification. Can you write in the chat box whatever answer you are thinking is right? Yeah. So, yeah, C is the right answer. That is a rainy afternoon. We already have discussed that tropical climate, we are talking about climate, and climate is the average of the weather. Polar climate, we are near to the pole, and there will be different type of weather, and average of that weather near to the pole uh, will be your polar climate. Arctic amplification, we will discuss about it in later slides. The remaining one is which is the right answer, that is a rainy afternoon. And yeah, as I told you, in at a particular location at a particular time, this is the temporary condition of your atmosphere. So rainy is a temporary condition. So that's how C answer is the right one. Okay, so you can see we can have different weather examples. It may be sunny, it may be cloudy, it may be overcast, that we don't have rain, but the cloud is covering your atmosphere, and this is how this is overcast. Then we can have thunderstorm, we have partially sunny, we somewhat cloud we have, and sometime we have the sunny, and this is how partially sunny we may have. Fog condition is also one of the weather example. Showers, heavy rain, rain with sun, snowy, partially cloudy night, unknown data, rain night, sleet, cloudy night, and so on. So these are different weathers that we can have. More than that, actually, these are just a few examples. Okay. The next question is related to which is determining or influencing the weather. So the question is, which atmospheric variable determines air movement and the development of weather systems? So we have four options here: atmospheric pressure, vegetation cover, ocean salinity, and surface geology. Which variable determine air movement? So I think the environment student, geography student, and even the climate student will be very will be very comfortable answering this question. Okay. So, what I learned is that A is the right answer. That is the atmospheric pressure. So, we do know that we have air, and if air parcel need to move, there should be some gradient, right? The low pressure and high pressure. And if we have these two pressure we have in the atmosphere, then air will move from high pressure to the low pressure, right? And this is what we like in everyday life we have experienced it, right? So if we have a low pressure somewhere and somewhere it is high pressure, then it will release and it will go to the low pressure, so that an equilibrium can be maintained every time. The nature is like that only. Nature wants to neutralize everything, wants to equilibrate everything, and that's why wherever there will be some gradient, either it is height gradient or if it is a pressure gradient, nature wants to mix that gradient, and that's how it will neutralize the things. So for example, uh, we have because of the warming, the air is very warm and warm air will rise up, and that's how it will create, and the particle of the air will be spreaded, right? Because these particles have a lot of energy and they will spread, and that's how it will create the low pressure zone. And if we have, let's say, the cold atmosphere in which the particles are not moving away from each other, that part of your atmosphere will have high pressure. And then with the time, what will happen? This high pressure air will move to the low pressure, and this movement of air is known as wind. You all know that, right? So the air movement and the development of weather system is mostly determined by the atmospheric pressure. I think you agree with me. The options that we have: vegetation cover, this is not determining the weather system, but this is determining the climatic system. We will talk about this. Ocean salinity is also influencing the climate, but not the weather. You can ask me anytime whenever you are thinking I'm just giving the statement without any reasoning, then anytime you can stop me and you can ask me why this is right. And this surface geology is also indirectly influencing the climate but not the weather. So the right option that we have is the atmospheric pressure. Okay, so the factor that are affecting the weather, the one and most important one is the atmospheric pressure. Then we have temperature. Because of the temperature, and there will be how your energy, the sunlight gave the energy to the surface, and how this energy is distributing to the atmosphere is dependent on temperature also. And this temperature is also important for the precipitation. We will talk about Indian monsoon also. Then humidity. Humidity is if you have heard the um, terminology, that is the dew point, right? And this humidity is actually determining how much warm you are feeling. For example, you have temperature that is 15 degree at two places, but humidity at one place it is 30-degree humidity, and some other place it is 70-degree humidity. So how much warm you are feeling will depend on the humidity. More the humidity, more warm and more um, kind of environmental anxiety you will feel. So yeah, humidity is also determining the weather. Then wind pattern. Wind is very important. Like your atmospheric circulation is all about the wind distributing heat, energy, and moistures. So we will talk about this in later slides. and precipitation. So these are the factors that are affecting your weather. Okay, the next question is, because we are talking about the weather event, and one of the weather events is cyclone. So cyclone generally form in areas of, and we have four option here: stable humidity, low pressure, high elevation, weak sunlight. Just give me 1 minute. Okay, so sorry. I got the response that is B. So the cyclone generally form in area of low pressure. I'm not going deeper into how cyclone is formed, but it is just give. Let me give you brief introduction about it. So we have ocean, and in the summertime, if ocean is warming enough, the it will give rise to your air will be warmed and it will go to up, right? And it will go to up, and you know that at some height we have a temperature that is lower than the atmosphere, and that's how the moist air that is rising will form the clouds there, because condensation will happen at some height. And so the first thing is you must have moist air that is going up at some height, the cloud will be formed. And the third very important point is Coriolis force. So near to the equator, Coriolis force is near to the zero, and that's the reason why we don't have cyclone very much near to the equator. After 5 degree north we can have this cyclone, but near to the 0 degree we don't have cyclone, because at 0 degree we the Coriolis force is zero. Okay, and so if we do have Coriolis force due to the rotation of the earth, your wind will also rotate, and due to wind shear and due to the low pressure zone, because of high temperature rising, the moist air leaving that area as a low pressure zone will create that cyclone. So yeah, B is the right answer, that this is the low pressure zone where cyclone can be formed. But the important thing is we must have moisture. Moisture will mostly be present in the ocean. Then we must have some Coriolis force, and we should have wind shear. So that's how the cyclone will be formed. So this is how we should have warm ocean water, and the temperature is given here. This should be 26 to 27 degree Celsius. We should have Coriolis force, as I already have told you about the rotation of the earth and the generation of this Coriolis force. Low level disturbances we should also have, then upper air disturbance, wind shear, and high humidity. As I told you, it is generating from the ocean, it is taking the moisture from ocean to the up of the atmosphere, and that's how these are the condition for the tropical cyclone. Okay, now coming to the next question. Temperature is important for precipitation because it drives. I think this is a very simple question about how the precipitation happens. And we have four options here: soil erosion, ocean circulation, evaporation and condensation, mountain formation. Yeah. So for the precipitation to happen, the we must have clouds, right? And how these clouds will be formed? cloud is made up of water, right? From where this water will come? From the surface. And how come surface can give the water to the atmosphere? And this is because of the evaporation, right? And that's how the C answer is the right one. So I think you all are much aware about this, that um, we have ocean, we have ponds, and we have rivers from where uh, water will be evaporated. And this evaporation is possible just because of the sunlight that we are getting on the earth from the sun, right? So sunlight will give some energy to the surface, and this surface can be the ocean, maybe pond or river. So if we are getting enough energy, the water is getting enough energy, water will start to rise up, it will start to boil, you can say. And that's how the phase will be changed from water to vapor. And this vapor will go up if we will have more energy, more temperature. And at some height we have low temperature, and that's how condensation will happen. Again, it will be in the water form, and it will create the clouds. And if we will do have enough cloud and enough moisture in the atmosphere, and the capacity, now if the capacity is saturated, then it will go down, and it will be the precipitation, either in the form of snowfall or in the form of rainfall. So evaporation and condensation are important processes for the rainfall, from for the snowfall. And evaporation is possible just because of um, the warm climate, or because of the temperature, right? So C answer is the right one. I'm not going much into that, but you just need to understand that in India, let me take the pen. Yeah. So in India, we do have rainfall, and we call it as the monsoonal rainfall, right? Or it is the monsoon. And most of the time, what we have is this is your Arabian Sea, and from that Arabian Sea, the moisture is coming, and it is giving rain first to the Western Ghat part and to the Mumbai, and then it is covering all India, right? So this is possible just because uh, the ocean will be warm, and because of high temperature, and evaporation will happen, and that's how yeah, it will move from ocean part to the land part. And so whatever precipitation we are having right now in India is just because of the temperature gradient among landform and the ocean, and the evaporation that is happening, that happened from the ocean. So so this slide is about that only, that Arabian Sea, you have there will be the temperature will be, let's say, 10 degrees Celsius, then there will be evaporation, and then it will go to the land part or the western coast. And that's how, because these air also have moisture, and it will create clouds, and yeah, it will be rainy. Yeah, I already have discussed about this, so I'm skipping right now. Okay, wind pattern redistribute, and we have four options here: minerals and sediments, salinity and nutrients, clouds and mountains, heat, moisture, and pollutants. What is basic role of wind? Moving air. Mhm. Can I get more answer from the audience? Yeah. So I got enough response, and all response are referring the D answer, the right one. So the heat, moisture, and pollutant. Sometime wind is good for us, sometime it is bad for us, but most of the time it is good for us. It is distributing the heat, right? So um, I will show you actually. You must have learned about your air parcels that we have globally, atmospheric circulation, and what we learned from it, that most of the time it is from the tropical region, because tropics are getting a lot of sunlight and it is warming the air, and that's how all the energy from the tropics, it is going towards the polar region, and that's how it is redistributing the heat. It is redistributing the moisture, as I gave you the example of the monsoon, right? We are getting monsoon because moisture is getting transferred by the wind from ocean to the land of India. And pollutant, how we can forget about this? uh, so so let's say we do have some industry area, and if we have some pollutant, that pollutant will not be concentrated over this industrial area. If we have wind, if we do have moving air, then what we can say is that pollutant can be redistribute, and pollutant can and then can move from one place to the another place. And this is just the wind, not just the wind actually. There is a lot of important parameters that are setting up the pollution over Delhi in the winter time. So the important one important parameter is the wind. So in the winter time, when we don't have much wind to distribute the pollutant that we are generating from the vehicle emission, and if the wind speed is very low, it will not distribute, it will not go from one place to another place, and that's how Delhi becomes the gas chamber. So wind is also among one culprit, that this is still air, this is not the much moving air over Delhi over that period of time when we are facing extreme air pollution in the winter time. Anyway, so wind pattern redistribute heat, as I told you, from tropical to the polar region. Moisture, as I told you, from ocean to the land. And pollutant, uh, from one place to the another place. So this is how the energy or heat is getting distributed. Right now I'm not going much detail into this, but whenever we will have more question like that, then I will explain it later. Okay, so I got one question. Will the certification exam consist of only MCQs or any other form of question? Till now I do have knowledge that it will be MCQ, but I'm not sure. So this is 90% sure, but I will confirm it. I can ask to Somil sir, and then in next week I can tell you about this. But right now I'm not sure about whether it will be MCQ or subjective type of question. Maybe right now I'm not clear much about this, so I will ask. And thank you for asking this question. Okay, we have learned about weather and weather events, right? Uh, we talked about cyclone, right? We talked about the factors that are influencing the weather. Now, there are some weather events that we need to go through. The one is Hurricane Katrina. The second is European heat wave, and the third is local thunderstorm. And we have some question on these also. So let me discuss about this one by one. So Hurricane Katrina made landfall in Louisiana as which type of category of hurricane? Was it two, three, four, five? Okay, yeah. So B answer is the right one, that this is category 3. So it's like everything we classify the level of an event from low level to the high levels, or in that type of way we also categorize our event under some categories, right? So the Hurricane Katrina that happened had the category 3. And let me tell you, okay, so such type of hurricane is not happening every year. And if it is happening every year, or having some particular frequency, then we may call it the climate. But it can happen anytime at any space, and we don't have that particular confidence over last 30 years that this will happen at that place or at that time. So that's how we are categorizing this, um, categorizing this as the weather event, but not the uh, climate event, right? I got the question, can explain the categories. uh, right now I don't have absolute values, because for each category we have, let's say, what kind of wind speed we must have. So I don't remember the wind speed and all. Based on that we have categorized this. But this you can just right now you can just think of it from low to high, and if we are going from category 1 to 5, you can read about this. Otherwise I can give you more information in the next week, because I don't remember right now the wind speed on which base the categorization has been done. Okay, so this Hurricane Katrina that happened in 2005, bringing wind of 140 miles per hour. And this wind speed is huge, and storm water that flooded more than 80% of New Orleans. So this is in USA. And typically more than 1,800 people lost their lives and damage across the Gulf Coast, and that topped $108 billion. So from here, what we understood is that um, these weather events, first thing is that we need to know about the science of this weather event, so that either we can adapt to it, or we can generate the building capacity to combat such type of weather events. Okay, so for the policy making, it's very important for us to learn about these weather events. Okay, so the next question is, in Europe, heat wave was happened in 2022, and the temperature exceeded to what degree? Celsius, 35, 40 degrees Celsius, 45 degrees Celsius. In India, we have this 30-degree, 35, 40, and even we face 45 degrees Celsius mostly every year. But for the Europe, this was kind of heat wave. So, uh, what temperature Europe has experienced in that heat wave? Any guess about this? You can give me wrong answer also. No worries. I will correct, because I do have right answer. I will tell you. But you can guess like what temperature can be considered as heat wave. Okay. Dr. Barunda told me that this is 40 degrees Celsius. And yeah, I completely agree with this. So in Europe, uh, temperature um, exceeded 40 degrees Celsius. And that's how it was declared heat wave. And you will be surprised that no doubt for the tropical countries we are like for us this 40 degrees celsius is not much because actually this is the adaptations that we have, but in Europe they need to uh, they need to do the adaptation because they never experienced such 40 degrees celsius temperature. And believe me, uh, last year when I visited there, and what I learned that they people don't have AC, they don't have fan, even they don't know about the coolers, right? So can you imagine that they people don't have fan, AC and cooler, and now they are experiencing the 40 degrees celsius because um, um, last decades they people had just 25 degrees celsius temperature or maybe 30 degree celsius temperature, but right now if they are getting this 40 degree, then how they will survive? And that's and in Europe we also have moisture, and that's how moisture, humidity plus the temperature rise unexpected is giving the European heat wave. Even this year also heat wave was experienced in Europe. And the another thing in Europe right now is that uh, in Europe there is a because it is near to the summer time or the daytime is too much long. So for example, it is from 5 a.m. to 8 or 9 p.m. it is just sunny day, right? And after that there will be night, so the night time is too much short, and the people are experiencing a lot of sun and sunlight in let's say from 5 a.m. to 9 or 10 p.m. So this is how it is very different condition in Europe as comparison to the India. And yeah, so 40 degree was declared as the heat wave in Europe. Okay, so it was driven by the combination of human induced climate change, stagnant atmospheric circulation. Right now, also in this year, there was heat wave, and the region was the Omega block that is trapping the hot air and severe soil moisture deficit. So these are the reason why we have heat wave over the European region. So you can see here, this is Poland, this is Germany, and Czech Republic, and this France. And can you see that the temperature is near to 30 to 35 to 40, and it was not like that 10 years ago. Okay. Uh, the another weather event is local thunderstorm is typically characterized by gradual cooling over decades, low rainfall and calm winds, persistent regional drought, heavy rain, lightning, and strong winds. In this week we are just touching um, some events and some terminology only, but in later on in later weeks we'll start with the extreme and how we can calculate the extreme, about the probability distribution and a lot. But right now we just need to be familiar with the terminologies that are related to the climate change and extremes. So that's why we are learning few things and very general thing this week. Okay, so I learned that people give me D answer, and yeah, I also agree with this. That if it is a thunderstorm, so thunderstorm is typically characterized by heavy rain, there may be lightning, and there will be the strong winds. So yeah, so this is how we characterize the local thunderstorm, like this. Okay, now we are moving from weather to the climate. Okay, so to define the climate, how much year data we should have? 10 year, 30 year, 15 year, 20 years. The minimum period for defining the climate. Yeah, so this is 30 year. To yeah, so let's say if we do have weather, and that kind of weather is persisting over a particular place and at a particular time for the 30 year, then we can classify, okay, this is climate, right? So for example, in Himalayan area, due to elevation, we have low temperature there, right? And this temperature is different from the plain area. In plain area we mostly have warm, and but in mountain region we are having the colder. But over the year, over 30 year, in the mountain we are having the colder temperature, right? And that's how in the mountain we can say that this is the cold climate, and on the plain area we can say, okay, this is warm climate. Because over the year it is not changing much, the mean is not shifting. If mean will shift, then we will call it as the climate change or something like that. But if we do have average weather over there for 30 year, if it is a colder, then we will classify this as the cold climate, right? So this is how. So we need at least 30-year data set to define the climate at that particular place. Okay. So this is again the slide I got from the NPTEL. That is, the climate is the long-term average of weather over an extended period, and that is typically 30 year or more. And the characteristics of this climate is that it is the long-term trend. It include average, variability, and extremes. And the example is tropical climate, polar climate, and so on. So here you can see that in India, we mostly have arid region, and we also have tropical region, right? And that's how we can classify our climate based on that. So um, as we are all aware that in Rajasthan, let's say we have very minimum rainfall that we are having every year, and that's how we they will classify it as the arid climate, because we don't have enough moisture here to grow the trees or to grow the crops, provided we are giving the irrigation to that place, right? Okay. In the analogy presented in the lecture, climate is compared with what? Behavior, emotion, mood, personality. Yeah. So in the lecture, it was said that the weather is like the mood. We can have any kind of mood. We can have angry, we may be silent, we may be talkative at particular time, right? So weather is kind of mood, but climate is kind of personality. It will be persistent, it will be same, no doubt. There may be some changes, there may be some mood for some time, but your personality will be like same. You will be the person with have some particular personality. So like that only, the climate is like the personality that a person has, but your weather is like the mood, it can change anytime. So yeah, D is the right answer. Okay, so what factors can influence the climate? The first is latitude, as we already have studied that near to the equator we have tropical climate. If we are going up near to the pole, we have polar climate. So because of this latitude, climate may differ, and that's how this is influencing your climate. First is this part. Then the elevation. Again, I told you, uh, at same latitude, at one place it is plain area and another place it is mountain area, then climate of two places but having the same latitude will have different climate, and this is because of the elevation. You can take the example of mountains that we have, right? Then the ocean currents. These are very important because these are distributing the heat. Again, as I told you, in the atmosphere, wind is also distributing the heat, moisture, but in ocean also, the heat is getting transferred from tropical to the polar. We will talk about it we will talk about it briefly. Then vegetation. You know that tropical climate have different type of cli- uh, tropical climate have different type of vegetation or forest type as comparison to the mountain areas. If we are going to the mountain area, we are having the coniferous type of trees, right? But in the tropical area we are having broadleaf, we maybe have deciduous and such type of forest we can have in the tropical, or the evergreen forest we have, like the Amazon. So the type of vegetation that we have can also determine the climate at that particular place. So for example, Amazon forest, rainforest, is kind of controlling in some way, not 100%, but uh, to some proportion it is controlling the climate near to the Amazon rainforest, right? And we can't ignore human activities that we will talk about it in next slides. Okay, so now the questions are related to the factors that are influencing the weather. So which factor determines the angle and intensity of incoming sunlight? We have four options here: latitude, humidity, vegetation, air pressure. You can write in the chat box whatever answer you are thinking is appropriate or right. Okay, so I got response that is A, latitude. Yeah, I think from class 7th or 8th standard, we started to learn that in near to the equator the sunlight is straight, right? And that's how we are getting more sunlight to the equator. But if we are going to the polar, then there is inclination, or there is some angle, and because of that angle sunlight has to travel a lot, and that's how uh, this sunlight is spread to more area, and that's how uh, your most of the sunlight that we experience is at the equator, but less sunlight or energy we are getting to the polar, and that's how there is a gradient that we find on our earth, right? So this is latitude, which is determining the angle and intensity of incoming sunlight. This is something like that. We have sun, and sun is giving the rays over a narrow area, and that's how it is getting more energy here. But here it is inclined, and the sun rays spread over a wide area, and that's how here we will have deficit of energy. And if we have surplus energy at the tropical, deficit at the polar, there will be gradient, and your wind will move from tropical to polar, and ocean current may also move from tropical to the polar. No doubt there are some ocean current that are moving downward also, but that's how the heat is distributed, with the help of ocean current, with the help of your wind circle or atmospheric circulation. Yeah, I think you all are aware about this thing. Okay. Temperature decreases with altitude at approximately 3.5 degrees Celsius per kilometer, 6.5 per kilometer, 8.5 per kilometer, and 10 degree per kilometer. If we are going up, let's say if you are hiking on the mountain, after 1 kilometer you will with the elevation you are experiencing the low temperature. So let's say um, on the plane you have 40 degree, but if you will go to 1 kilometer up at some on some mountain, then you may feel less temperature. But how much less? Typically how much less? There may be some variation, but typically how much less temperature you will experience after hiking to 1 kilometer up on the mountain? uh Actually, typically it is 6.5. It is 6.5. So let's say it is the plain area and you are hiking. This is your mountain, and this is 1 kilometer, and this is 2 kilometer. And let's say here we have 40 degree Celsius. So at 1 kilometer, we will experiencing some 33.5 or 34.5, sorry, or 33, yeah. 33.5. Yeah, I will tell you any specific reason for this. Uh, okay, the first let me tell you that. Okay, so what I told you that it is approximately 6.5 degree drop per kilometer. Sometime it can be near to 5, or sometime it can be near to 10 degrees Celsius, but typically it is 6.5. And this drop with the elevation is known as, can you tell me the terminology that is related to uh, okay, uh, at about 1 kilometer? So you need to minus so at 2 kilometers, so this will be 40 minus 13. Yeah. So I Ganguly gave me the terminology that is the right one. This is known as the lapse rate. Decrement in the temperature with the elevation is known as the lapse rate. Okay, now the question is, one question was asked, why this is happening, what is the reason for this? And the reason for this, there are two reasons actually. The one is we have thin atmosphere, as we are going up. And what will happen if it will be the thin? So the first point is, it is the thin atmosphere above that is driving this decrement in temperature with the altitude. The second is very important, is that uh, we are getting sunlight at the surface, right? At surface. So, and you know that, let's say this is your surface, your sunlight is coming to that surface, to the plain area. Uh, yeah, that's what I'm trying to explain you, that sun is more closer, but still we are having low temperature. That's what I'm trying to explain you, that the warming that we are having is from the surface. Okay, so this is something that your sunlight will come and it will strike on the surface. Okay, and if it is striking on the surface, the air near to the surface will be warm first. It is not like that. The warming is not here. Warming is not here. Warming will be first after it's striking to the surface. After striking the surface, there will be some energy. That energy will be taken up by nearby air, right? And nearby air will be warm, right? So what I want to say is that on the surface, um, this sunlight is giving the warming just after striking on the surface, and that's how it is. The air is getting warmed near to the surface, and more you are away from that surface, less energy you will get upward, right? So the conclusion is that the sunlight is coming downward, but you know that this is short wave radiation, and your warming is due to the long wave radiation, and long wave radiation, it will convert only when it will strike to the surface, and when it will strike to the surface, it will convert into the warm long wave radiation. It will warm the air, and that's how the warm air will interact with the air that is above to it. It will make it more warm, it will make it warm, but it will lose the energy, right? And that's how near to the surface there will be high temperature, but as we are going up into the atmosphere, because more energy is near to the surface and it is transferring from surface to the up in the atmosphere, and that's how at the atmosphere this is called a temperature. I think this is the one explanation, and the second explanation is this is the gravity, right? Because of the gravity, we have more concentration of gas near to the surface, but less concentration of gas in the above, because you must have experienced low oxygen at high elevation, right? Why this is happening? Because our gas are denser. If our gas have some density, more gas composition will be near to the surface, and above that surface we have thin atmosphere, and thin atmosphere again will lead to the cooler temperature. Okay, so these are the two explanations why we do have that lapse rate, and we can't ignore the microclimate that we have on the mountain region. Okay, so I think there is a lot of discussion over this. Yeah, so this is what I wanted to show you, that atmosphere is divided into four parts. You must have aware about this: troposphere, stratosphere, mesosphere, and thermosphere. Can you see this latitude? This latitude is increasing. In troposphere, your temperature is decreasing. Can you see the minus sign here? So this is something minus 52 degrees Celsius at the top of troposphere that we have, and the height is near to 13 kilometer. So near to 13 kilometer we have temperature of minus 52 degrees Celsius. But this is what I talked about, the lapse rate. It was more for the troposphere, but in stratosphere the condition is very different. We have ultraviolet radiation that is coming, and this ultraviolet radiation is giving the warm. With the elevation, the temperature is increasing, so troposphere is different from the stratosphere. In the stratosphere, temperature increase with the elevation. Again, in mesosphere, it is like the troposphere, but more temperature down, more temperature decrease with elevation. And again, in thermosphere we have a lot of ions here in this environment, and that's how again we are having the temperature increase with the elevation. So this is how complex our atmosphere we have. And we talked about this dry adiabatic lapse rate. Okay, so as I told you, environment lapse rate is typically 6.5 degrees Celsius per kilometer decrement in temperature. But if our air parcel is dry, if our air parcel is dry, then this lapse rate can be 10 degrees Celsius. And if our air parcel have some moisture and it is saturated, then your lapse rate will be changed and it will be near to 5 or 5.5 something, right? So it depend on uh, the air that is rising up, it has moisture or not, it is dry or it is wet. Based on that, the lapse rate will also be changing. So I think that's enough for the lapse rate. You can talk about there is um, a lot of information that we need to know about this lapse rate if we are talking about the pollution. So let's say we have a chimney, and if chimney has a stake and your pollutant is spreading from that stake, whether your pollutant will go down or will go up or will go straight, you must have seen that uh, chimney is giving the plume, and that plume have different shape. Sometime it is going up, sometime the plume has shape that is it is going down. And this is just because the condition that we have of atmosphere. You can read more about this. Okay, so what we were talking about is the factors that are influencing the climate. And the another factor, so uh, we talked about the elevation, we talked about latitude, and now let me talk you about this ocean currents. So ocean currents influence climate mainly by increasing air pressure, producing land erosion, redistributing heat, and reducing latitude. Yeah, so we already have talked about this, that oceanic currents that we have in the ocean are redistributing the heat. As I told you, suppose we have ocean near to the tropics, there will be a lot of sunlight that are coming, and a lot of energy will be stored by the ocean that is near to the tropics. And if there is a gradient, polar will have deficit of energy, right? So the ocean near to the polar will have very less energy, and there will be gradient. Near to the polar, the water will be very cold. Near to the tropical, the water is very warm. And that's how there is a kind of gradient that is creating here. And because of that gradient, your water will move from your tropics to polar. And that's how, if water is moving, it is also carrying the heat, it is also carrying the energy. And that's how ocean current is helping to redistribute the heat, right? um, one I talked about is the temperature, warm ocean and the cold ocean. But along with that, there are different gradients that can be formed in the ocean. Maybe, let's say, because of the salinity, right? Can you tell me, the salinity will be higher near to the polar region or near to the equator region more? More salinity will be near to equator or near to the polar? Okay, so I got answer equator. 1% told me the mid latitude. Okay, and I'm not discussing about this, but you just need to learn more about this thing, that salinity is not differing latitude wise, but also with the height of the ocean. We know that. Again, one example, that let me draw it. Okay, so what I told you, that over the surface we have more energy that is coming, right? And that's how here in the air we have cold temperature, cold atmosphere, and this can also apply to the ocean. So this was the atmosphere part. Now we have ocean part also. Ocean will be warm near to the atmosphere, near to the surface, but this energy will go down step by step, layer by layer, and that's how here the temperature of your ocean will also be low. Okay, and if the temperature of ocean is low, the salinity will be very different at the bottom and um, at the surface of the ocean. And there is a salinity gradient with the height, with the latitude, and there is gradient in the temperature of the water of the ocean. And the third thing is that we have surface and the wind is moving, right? Let's say wind is moving here in the atmosphere, it can push your water of the ocean in one particular direction. So because of the wind, because of the salinity, because of the temperature gradient, there is the movement of your oceanic water. And if there will be the movement, the energy will be redistributed. So the answer is redistributing the heat. So you can see here the surface current caused by the wind, deep oceanic current caused by difference in density. The cold water will be more dense as comparison to the warm water. So at the bottom, you have more dense water as comparison to near to the surface. Oceanic water will be more warm, and that's why less dense. These are actually the oceanic currents. You must have learned about this in 11th, 12th standard if you have taken up the geography. So this is the figure taken from NCRT only, 11th or 12th, I don't remember, but yeah. So the red color is showing that this current have the warm water. So for example, this is red, so it means it is carrying the warm water. And if it is this purple color, it means the oceanic current is having the cold water, right? So if you can see near to the equator, this is the warm water. Okay, and this warm water will go, can you see in that way it is going? So from the equator, near to the equator, it was equatorial current. Then it changed to the Gulf Stream because it was near to the Gulf area. Then it turned into another oceanic current, that is North Atlantic Drift. And that's how the heat, the warm water that we had in the ocean is carrying the energy, carrying the heat to the polar region. And that's how this is making the earth habitable, right? And again, we can see here, uh, here near to 60 degree south, we have cold temperature and this cold oceanic current, and we are this low or cold oceanic current is also moving to the equator. So okay, if this possible, could you explain why current move clock and anti-clockwise in north and southern region? Uh, This is I don't know exactly about this because right now I'm not a oceanographer. My study is mostly based on vegetation, but it may be really I don't know exactly what can be the reason. Maybe geography people can explain it better, but maybe this is the atmospheric circulation and Hadley cell that may be driving this direction near to the equator, but I exactly don't know the right answer for this. Any geography people can raise the hand and can explain this? Is any geography people? Okay, so Ganguly told me that this is the rotation of Earth. I so can you tell more about this, Ganguly? Because I don't know how this rotation of Earth will lead to the clock and anti-clockwise in northern and southern region. Okay, Kailash asked again that, but it is same as whole. Daguli, can you answer this? Because I don't have expertise in this oceanic currents. I'm not geography people. Um, okay. Anyway, it may be that um, ga- um, rotation is in the same direction. Okay, Kailash told me that rotation of the earth is in same direction. Yeah, I also agree. Then why this is clockwise and anti-clockwise? There must be some reason, but I am not like I have very limited knowledge about this ocean current because this is not much like it was not relevant to my study area, so I didn't read about this. Okay, Gaguli gave me one answer that deflective force generated by Coriolis force that regulate the flow of fluid like air also. That makes sense actually. I also learned that yeah, this is due to Coriolis force in the north hemisphere and southern hemisphere. This is like different clockwise and anti-clockwise. So yeah, that can also make some sense. Okay, thank you, Ganguly, for giving the answer, and thank you, Kailash, for asking this question. I also learned from it, so thank you so much. Okay, let me clear this. Okay, you can ask a lot of question about this vegetation because right now my work is on vegetation and climate. Uh, okay, so the question is vegetation affect climate through changes in, and we have four options: tectonic activity, ocean depth, atmospheric mass, and surface temperature and humidity. Yeah. So, oh, how? No, atmospheric mass is not the right answer. The D answer is the right one. That is the surface temperature and humidity. So let me explain you why this is surface temperature and humidity. So as again I told you that we have sun, and sun is giving a lot of sunlight, and this sunlight can be intercepted either by the canopy or it can go to the surface also, to the soil. And if it has been intercepted by the canopy, then there will be evapotranspiration, evaporation plus transpiration that plant does. And because of that evapotranspiration, a lot of water in the form of vapor will go up. And so there is the one terminology that is the latent heat flux. So because of this transpiration, uh, the phase of your water will change after getting the energy from water to vapor, and that's how the vapor will rise up, and this will create the cooling near to the forest. So this is how, if you have trees nearby to you, and in so if it is a summer, then this evaporative cooling due to latent heat flux can give you more cooling, right? But if you don't have forest in that particular region, then this phase transition will not happen until or unless this is pond or river, something like that. So if we have bare soil, if we do not have trees on this, and if soil doesn't have enough moisture, then what will happen? Your surface will be warmed, and this will also warm your air nearby, and that's how this will give you more sensible heat flux. And so based on how much energy you got, and a forest will decide how your energy is getting distributed, either in the form of latent heat flux or in the form of sensible heat flux, and what is the proportion of these two fluxes, and that will determine the surface temperature, right? Along with that, so this is just the one thing. The second thing is that forests have different color as comparison to the soil, right? And albedo is depend on either your surface is darker in color or it is lighter in color. So the sunlight reflectance, let me tell you, if someone doesn't know about this, the reflectance, or the short wave radiation that is coming from the sunlight is reflected back, and this is known as the albedo. And this albedo is dependent on the color of your surface. For example, if you are in glacier region, the color is white, right? And white means there will be more reflection of your light, and that's how this again is giving you the cooling impact. But and the same thing that we do, that we paint our house, or we wear the white color things, right? White means because it will reflect the sunlight, and that's how you will feel cool. But due to forest, the color may be darker, or it may give you more energy because the reflectance will be low, and that's how it is affecting the climate. Okay, the another way how it can affect the climate is CO2 sequestration. So why do we plant the trees? Because it is absorbing, it is taking more CO2 into its biomass, right? And that's how the tree captures the CO2. And that's how, and CO2 is the main culprit for the climate change. So this is how vegetation can impact or influence the climate, either through redistributing the energy, through albedo, through CO2. And there is a lot of mechanism that we can discuss about, by which vegetation can influence the climate. So yeah, this is hydrology and the carbon cycle that I already have discussed. Okay, uh, how climate is getting influenced. We talked about latitude, we talked about elevation, we talked about vegetation, and not to forget, we need to talk about the human influence on climate, because human is right now the main culprit, right? So, which of the following represent a human influence on climate? Greenhouse gas emission, latitude variation, mountain elevation, ocean depth. Okay, so I got a answer, that is greenhouse gas emission. Yeah, so human most of the time do the combustion, right? burning everything, so that after burning we can have a lot of energy. That energy we can store, and we can generate electricity. So what I'm talking about, the fossil fuel combustion, we are burning the coal, we are burning the petrol, diesel, everything. We are burning the LPG. So what we are doing is we are burning some carbon substance. Okay, we are burning some carbon based substance. For burning we need oxygen, and this carbon and oxygen will react and will form the CO2. And after this burning, after this combustion, a lot of CO2 will be released to the atmosphere. And CO2 is a very important greenhouse gas. What do you mean by greenhouse? So I think you all are aware, but let me give you brief discussion, brief information about this. So you have this earth, and earth have the atmosphere. So let's say this is your atmosphere. You have, so the sunlight will come and will strike on the surface of your earth. And then, so this is the short wave radiation that is coming from the sunlight, from the sun. And then after striking, it will be the long wave radiation, right? It will be the long wave radiation. This long wave radiation will not go directly to the space. This is not happening, but because in atmosphere we have a lot of gases, for example CO2. So what CO2 will do, CO2 will take this uh, long wave radiation and will redirect toward the surface. So, so this is creating a blanket. It is not allowing the long wave radiation to go directly to the space, but is redirecting this radiation to the surface. And a lot of time, if this radiation is redirecting toward the surface, then what will happen? Surface will warm more. If we will have more CO2 in the atmosphere, then a lot of radiation will be go back to the surface, right? And a very few will go to the space, and this will create imbalance, in minus out. And imbalance means there will be positive radiative forcing. Okay, if there will be positive radiating forcing, it means whatever energy we are getting, it is getting changed into the long wave, but this long wave is again and again striking to the earth. So this is warming the earth, right? And this is what we are doing. By combustion we are increasing CO2 into the atmosphere, and that's how we are playing with our atmosphere and its nature, right? So this is greenhouse gas emissions. Based on that, we are influencing, or we are changing our climate. So the answer is greenhouse gas emission. I already have given you the example. The CO2 is one. There may be different gases that can do the same work, but with different intensity. And so we have methane. Methane is also one of the greenhouse gas. Then water vapor. This is again greenhouse gas, and we have a lot of greenhouse gases right now in atmosphere. We will talk about this if we will have same this type of question. Okay. Uh, Now, we talked about climate. We talked about what can influence the climate. Okay. Now, there are some example of climate patterns. These are not the weather events, but these are the climate patterns which are well known over with the 30-year or more than 30-year data set. The one example is ENSO. We will talk about this, in which we do have two terminology, that is El Nino and La Nina. So sometime you must have heard that the monsoon will not be aggressive this year. Or sometime it is like that our rain will be more as comparison to the normal. Why this is happening? So most of the time this is happening due to El Nino and La Nina processes. So if it is El Nino, it means the monsoon that we are getting will be weakened, and that's how uh, there will be less rainfall in India and during the monsoon season. And if this is the La Nina condition, it means a lot of moisture will come from the ocean and it will give you a lot of rainfall over the Indian region. So, and this El Nino and La Nina are based on the temperature of your ocean, specifically the Pacific Ocean. The Pacific Ocean is warm or colder. Based on that, there are some circulation, and based on that circulation, we decide that whether the moisture will be enough to reach to the land part, and what is the amount of that moisture. So uh, El Nino mostly gives rise to drought, but La Nina mostly give rise to precipitation extreme. A lot of precipitation we can have due to La Nina. Then another climate pattern that we have is the monsoon. Monsoon is the well-known thing, right? Over 30-year data, what we have learned, or more than 30 years, what we have learned, that from July to September, there is the reversal of wind, and this wind are carrying the moisture, and this moisture is coming to the ocean. This is happening every year, and that's why this is climate pattern. This is not weather, right? This is a monsoon is itself a climate pattern. Then Arctic warming trend. This is this is very horrible, but yeah, what it is that our Arctic region. Right now there is a climate change, and in the climate change, the temperature is warming, right? The rate at which the global is warming and the rate at which Arctic is warming is very different. Globally, let's say if the warming is 1 degree Celsius per 20 year, then at Arctic it will be 2 degree per 20 years. So this is how, this is the doubling of warming. The rate is double of the warming as comparison to the global average. So this is how, this is the Arctic amplification. Okay, so now the questions will be on climate patterns. So my first question is based on that. ENSO involve temperature fluctuations mainly in the, and I already told you about this. So we have four options: Pacific Ocean, Atlantic Ocean, Indian Ocean, Arctic Ocean. If sometime you are feeling that I'm moving so fast, or I'm not explaining the things, anytime you can stop me and you can ask me, okay, we are not, you are going very fast, or you are using terminology that we are not aware of. So you can write anytime that we want to know about this terminology or about it. So please don't be hesitated. Okay, so as I told you, there is different difference in the ocean water temperature over the Pacific over the Pacific Ocean, that is giving rise to El Nino and La Nina, right? So so this is Pacific Ocean. I have figured. So what you can see here, so this is your Pacific Ocean. This is Australian part, right? And here you can see most of the time, because of that wind that is pushing the air, right? Wind is pushing the air. These are the trade winds that are pushing your water toward this side. Because this is like, this is Hadley cell, if you know about this. So this is how the wind is pushing your water, warm water, toward this side, west side, right? Just because the trade wind is moving to that direction. So if this is happening, so what it is, that here we had low temperature of the ocean water. Here we have warm water because the trade wind is moving toward that, and it is pushing, and it is and that's how the upper layer of the ocean that is warmed, the upper layer, upper water is getting pushed to the west side, and then from below the water will come out, and that's how this is giving you the cold temperature, right? Because it is coming from the below. So that's how we have warm temperature in the west side, and in the east side we have cold temperature. And based on this, there is a circulation. Can you see there is a circulation that is happening, right? So, and because here we have the warm, so the moisture air will rise up, and there is some cloud that you can see, and raining will be happen in that area. Okay. And this is here also we have Indian region. Okay. And when, so La Nina is that this circulation is getting stronger, and a lot of warm water is getting a lot of energy in that particular region, and this particular region will get the rainfall. And here we also have this Indian part. But so this is the La Nina. In El Nino, what will happen? This is getting reversed. Can you see? It is cold temperature, and it is the warm temperature, and because of that the circulation will get reversed. So here there will be raining season, and near to the Australian part there will be drought condition. And so due to El Nino, Indian continent also face drought in El Nino condition, but in La Nina condition, India is also getting a lot of rainfall. So last year we had La Nina condition, but this time we have El Nino condition. So this El Nino, La Nina, that's are happening in the Pacific Ocean. Okay. Now the question is, La Nina is associated with warmer than average Pacific sea surface temperature. SST is sea surface temperature, cooler than average Pacific sea surface temperature, constant global air pressure, reduced monsoon circulation everywhere. So, La Nina is that it is getting cooler. Let me show you again. Yeah, here. This part, Pacific Ocean, is getting cooler, right? And that's how, and here there is a lot of warming pushing the water, and that's how here it will be more rain. So La Nina is associated with cooler than average Pacific sea surface temperature. Okay, the southwest monsoon contributes approximately what percentage of Indian annual rainfall? 40%, 60%, 80%, or 95%? Okay, this is just the stat, so I don't want to give more time on this. So this is 80%. Okay, so we must know that this is India, and right now we have the monsoon from July to September. So we call this season as a JJAS season. June, July, August, September. So this is our monsoonal time. So in that time, we have moist air that is coming, and it will strike to the Western Ghat and to that region. And that's how in India we have rainfall. But this is the rainfall in the summertime, but in winter time also we can have the rainfall due to this is southwest, but maybe due to northwest monsoon, and there is the westerly winds that are coming, and because of western disturbance, there is the one terminology you can read about this. There is the western disturbances, sorry, WDs. Because of this WDs, there may be rainfall near to the north part of the India. Okay, so the monsoon is giving approximately 80% of the rainfall, but 20% we can give the credit to northwest and this western disturbance event, and that's are giving more rainfall, and that's how it will complete your 100% rainfall over India. Okay, we already have discussed about this. Arctic amplification means the Arctic is warming at the global average only during summer, less than the tropics, more than twice the global average. I already have discussed about this. And the thing is, why we are worrying much about Arctic amplification? Okay, so D answer is the right one, that at Arctic, the warming is more than twice the global average. The rate at which globally there is a warming at the Arctic, it is kind of double or more than the double the rate. So let me show you. So can you see here? This is the warming uh, with reference to pre-industrial region, pre-industrial time. So if you can see in India, so this is uh, approximately this is zero point 0.5, right? Zero point 0.5 degrees Celsius, or we can Kelvin, because this is the anomaly. Then we can like there is a no difference in Kelvin and Celsius because it is subtracted value, difference value. So this is zero point 0.5 degrees Celsius that we are getting warming as comparison to our pre-industrial area. But here, if we are seeing in this entire Arctic region, so this is near to 2 or 1.5. So can you see that this is more than double? This is more than double. This is 300, 400 percent more as comparison to the warming that experiencing globally. So this is what it is, Arctic amplification. But why we are worrying about this? And why we are worrying about Arctic amplification? Because Arctic is full of glaciers. Yeah. And there is a melting. Yeah, you rightly said that there is a melting of snow. And if snow will melt, then your water resources will be gone. The first thing. The second thing is, as I told you, the glaciers, uh, not only your resources will gone, the another part is um, this will your white part of the glacier will be gone, so it will expose your bare soil, it will expose the rocks have the darker color, so your albedo will also be reduced, and that's how more sunlight will be here, more warming will happen. So this is ice albedo feedback, and this is positive feedback. More warming, more melting, more temperature. Yeah, Ganguly gave me sea level rise. Obviously, this will happen because a lot of water from the glacier will go to the ocean, to the sea, and the influx of water, if we are experiencing, then the sea level may rise. And then the another point is saline water ingress into fresh water in coastal region. Yeah, rightly said that in Mumbai, it is said that after a few years, that ocean water will come and will cross this coastal region and will inund the Mumbai, and if this is happen, this all water may mix with the fresh water, and if it is mixed with the fresh water, then again there will be the depletion of your drinking water. This is a very grave situation that we have right now. Okay. So coming to the lecture two, that is related to the climate change. So climate change is best described as long-term change in climate elements, daily changes in atmospheric pressure, a single episode of heavy rainfall, short-term variation in cloud covers. Okay, so I'm getting answer A from everyone. That is the long-term change in climate elements. So can you give me the name of climate elements? So let's say, okay, one climate element that we know is the temperature, right? So the long-term change in the temperature um, is the climate change. If there is a long-term change in the rainfall also, this is also the climate change. What more we can have? Vegetation, actually vegetation is not exactly the element, but this is the feedback, um, or it will be the impact thing. Deforestation is again, deforestation is not directly the climate element. Actually, this is you can say consequences. Um, Ganguly told me cloudiness. Yeah, there may be change in cloudiness. So yeah, we will talk about this. But anyway, I will show you. Climate change is best described as the long-term change in climate element. Air pressure is, yeah, one of the things. Okay, so this is just to show you that what will happen after the climate change, uh, because it will impact on the because there will be change in the precipitation. That's how it will have impact on the soil moisture. It will have impact on the forest. It will have impact on the deforestation is actually human induced thing, right? So deforestation is not the right option here, but if there will be water deficit in the soil moisture, then the forest may die, and that's how deforestation can happen. So these are the consequences of the climate change. Okay, so we have different factors that are deriving this climate change. We may have natural factors. Because of volcano, climate may change. Due to solar radiation, change in the solar radiation, climate may change. Due to the change in the oceanic current by itself, climate may change. Due to orbital changes, climate may change. But obviously, the climate may change due to the natural things, but it take a lot of time to make the changes. But anthropogenic factors are the one which are making the change very frequently, and that's how we have confidence that right now the climate change is not driving by the natural factor, but these are the anthropogenic factors that are driving the climate change. Or this can be fossil fuel combustion, deforestation, industrial processes, agricultural practices, and waste management. Right? Okay. So now the question is, you have to tell me which one is the natural climate factor which can change the climate. Industrial process, volcanic eruptions, waste management, fossil fuel combustion. Yeah, B is the right answer. That is the volcanic eruption. So can you tell me what will happen if volcano will be erupted? How it will impact the climate? If there is the volcano is getting erupted in Philippines, let's say, what will happen? How it will change the climate? Okay, yeah. So one answer that I got is cloudiness and rise in the temperature. Yeah. So what will happen? Uh, because of that volcano, the plume, it will cover your atmosphere and it will block the sunlight, right? It will block the sunlight. If the sunlight is getting blocked, then rise in the temperature, there may be rise in temperature, but there are more reports that is giving the cooling of the temperature, because short wave radiation is not coming inside it. For 1 or 2 days or for few weeks there may be rise in the temperature, as we already have some energy near to the surface. But as there will be after some weeks or after some days, what will happen? We will not have short wave radiation that is coming to the surface, and that's how your temperature may be cool down, not rise in the temperature. And there is a one study in Philippines. I think this is the Pinatabu volcanic eruption that happened in 1991 to 1992. For that 1 year, there were a lot of aerosols also that were released due to volcano, and that aerosol is giving us the cooling impact. The first thing. The second thing is, because of that, agriculture, it badly affected the agriculture. So the people were deprived of agriculture yield just because of this condition. Then Ganguly told me that different gases come out and mix with the atmosphere. Rightly said that after volcano, because volcano is again one type of burning the things, right? Or lava coming out to the atmosphere. So because of that, CO2, a greenhouse gas, sulfur dioxide, and a lot of different gases, aerosols, will be released into the atmosphere. And again, this may CO2 is the greenhouse gas, then aerosol and particles that will be released. The sunlight will interact with this particle into the atmosphere, and it can change the climate, right? So yeah, volcanic eruption is the one of such climate natural climate factors. So like this, it will cover all your atmosphere, and it will be like the blanket. It will block your sunlight, and a lot of CO2 and sulfur dioxide and such kind of gases it can release into the atmosphere. So here you can learn about this more, how it will impact on albedo, how it will impact on the cloud formation also. So yeah. uh, Natural causes can be solar variation. You know that on sun we do have dark spots and bright spots, or light spot, you can say. So this is some part are magnet active and some parts are not active, and based on that, if that part will be coming near to will face the earth, then there will be change in the solar energy. Okay, so this is the solar variation. So sunspot we have on the surface of the sun. Then we have volcanic eruption. Then the axis can tilt of the earth, and that's also can give you the climate change. Then precession, there may be spinning the top. Eccentricity, the rotation, the orbital rotation that we have, it can change the path, and because of this path change, earth can come near to the sun, or it may go far away from the sun, and that's how there may be change in the energy on the earth, and that's how it can also give you the climate change. But the thing is that these are taking thousands of years for making the change of 0.1 degree Celsius. And but human are doing something different and very rapidly. Continental drift can also give you the climate change, oceanic current, natural forest fire, and the greenhouse gas naturally that we have. So, which one is an anthropogenic climate change factor? I think this is the last question. We will continue next week with different questions that we will have. Which one is the anthropogenic climate change factors? Yeah. So C is the right answer. Solar variability is the natural one. Orbital change is the natural one. Deforestation is human induced climate change because a lot of CO2 will be released into the atmosphere. Oceanic current is again the natural one. So deforestation is the anthropogenic one. I have more question related to the extremes, but I think the time is up and we will start with the climate extreme. How we are defining the climate extremes, shift from the mean, shift from the or increasing the variability. So such kind of things we will learn in next week. Till then, happy reading and have a good night and have a good food. So thank you so much. And if you have some query, you can just let me know. And anytime you can write me on the mail, that is Jyoti, JYOTI 2121 at the rate IISERB.ac.in. I can write in the chat box also. So anytime you can ask me your query if you have. And yeah, if you have any suggestion also, how should I proceed, what improvement you want in next week, you can just let me know. So thank you.